All right, taking a look at 24, the first thing I noticed right away, I don't know if you guys did, that lower limit of integration right there is really ugly, 8/27ths. But I hope you guys recognize what was going on right here. What do the numbers 8 and 27 have in common? They are both perfect cubes. And that tells me then that I'm probably going to end up taking the cube roots of these numbers at some point, which doesn't really surprise me because I've got fractional exponents with a denominator of 3. So I think I know where this thing is going. Okay, this problem right here is a little bit tricky because we're being asked to take an integral, so we're going to need an antiderivative of this messy integrand right here, which is a fraction that has variables on both the top and the bottom. All right, so I always think to myself, what rule would I need to differentiate this? I'd need the quotient rule. And if you need the quotient rule or the product rule, it's too complicated to simply reverse that rule. So what are we going to do instead? We're going to split this up, guys, into the integral, and I think just one integral will still be fine, from 8/27ths to 1 of this fraction right here minus this fraction right here. So I'll go ahead and write that out so I don't lose you guys here. 10t to the 4/3 power divided by t squared. And then a minus 8t to the 1/3 all divided by t squared taken with respect to t. Now I'll slide over a little bit here for the next one. What does that accomplish? I can now rewrite this as an integral, still from 8/27ths to 1, but I can simplify each one of these fractions here. Look at your exponents, guys. T to the 4/3, t to the second. Let's just do top minus bottom. This is going to be 10t and 4/3 minus 2. That's 4/3 minus 6/3. That's t to the negative 2/3 power. Now, if this were algebra 2, I probably would have rewritten this as 10 over t to the 2/3, but as it is right now, we're going to reverse the power rule in just a second. So writing things on one line with a negative exponent is really what we want to do here. Now for the second fraction here, that's going to be a minus 8, and then we're going to have a t, and let's look at your exponents again. 1/3 minus 2. That's going to get us a negative 5/3 for that exponent. And that whole integral is still being taken with respect to t. Now, it's ugly, but the way things are written right now, I think we're ready to go ahead and reverse the power rule. So let's take a look at the first term. We're going to have a t. We're going to raise our exponent by 1. So negative 2/3 plus 1 is going to be a 1/3. And then we take the old coefficient and divide it by the new exponent. 10 divided by 1/3 is 10 times 3. That's going to be a 30 right there. Now, probably a good idea to take just a second and in your head ask yourself, what's the derivative of that term right there? 1/3 times 30 is 10. T, and dropping the power by 1 would get you negative 2/3. So I think we're in a good spot. All right, what comes next here, guys? The second term here, we're going to have a t here. You're going to raise that exponent by 1. Negative 5/3 plus 1, or plus 3/3, is a negative 2/3. And then we divide the old coefficient, which was negative 8, by the new exponent, which is negative 2/3. Negative divided by negative means this term is now going to be plus. And then let's see, guys. 8 divided, let me do this off to the side. 8 divided by 2/3. Well, that means 8 times 3/2. What's 8 divided by 2? 4 times 3 is 12. So that could have been worse. Plus 12, t to the negative 2/3, all of which gets evaluated from 8/27ths all the way on up to 1. While we're at it here, guys, hope nobody's offended by what I'm about to say, but a lot of you guys are not great with fractional exponents. So what I think I'm going to do before I start cramming those numbers in is rewrite this thing with radicals. I would probably write this as 30 times the cube root of t, and then a plus 12, and then here, ooh, it's a negative power. So you know what? I'm going to make a fraction out of this and put a 12 on the top. And on the bottom now, it'll be the cube root of t. And you can either put your square here Or better yet, I think, oh, I lost all that. I think it's better to do the cube root of that first and then square that result. All of which now from 8/27 up to 1. So here we go. I'm going to slide back. Oh, that was strange. All right, I'm going to slide back left, and here we go. Brackets are your friend here, guys. Let's put in the 1. Well, this is pretty nice because the cube root of 1 is 1, so that's just a 30 plus that whole mess on the bottom is just going to be 1, so it's 30 plus 12. I guess I didn't really need brackets. Parentheses would have worked just fine right there. So that's what you get from evaluating capital F of A at 1. And then minus, now comes the fun part, let's put in 8/27. Whew. And just like I predicted, we're taking the cube root of 8/27. So that cube root is going to be 2/3, and 2/3 times 30 is going to be 20. Plus, okay, now the fun continues here. Let's take a look at what's going on here. The cube root of 8/27 we just said is 2/3. 2/3 gets squared to make 4/9. And now what we're doing is 12, and it's a fraction now, so it's divided by 4/9, which means 12 times 9/4. 12 divided by 4 is 3. 3 times 9 is 27. So that is what should have gone right here. So what do we have, guys? 30 plus 12 is 42, minus 20 plus 27 is 47, and 42 minus 47 looks like it's going to give us an answer here of -5. So a lot of work right there for problem number 24, but splitting everything up, we ended up with a relatively nice answer right there. Certainly could have been worse, of -5.